Hey everybody, it's Dr. J, and today we are talking about calculating concentrations using ice tables to figure out our equilibrium. Right? So let's talk about chemistry. Alright, so today, once again, we're dealing with equilibrium here, everybody. And we're going to look at this reaction. I2 plus H2 gives me 2HI. And we have our initial concentration. So the initial concentration for my I2 and H2 will be 2 molar. And then we don't have any product. All right, it's 0. And then we know our K is going to be 16. What will be the concentrations, all right, when our reaction reaches equilibrium? So with this type of problems, we're just trying to figure out, we're going to reach equilibrium. What are those concentrations for those different things? Okay. So first thing we need to do is write our ice chart out. All right. So you're going to write out your initial and your equilibrium conditions. So step one, we need to write our initial and equilibrium conditions. So you might have referred to this as ice, right? Shout out to Ice Baby. But your I is your initial, your C is your change, and then your E is your equilibrium, right? Your concentration at equilibrium. So in this case, we're trying to figure out our equilibrium. So initially, we know that we're at 2 molar for both of our products, reactants, right? 2, 2, and then we don't have anything for our products at 0. And then when we're talking about change, right? A couple different things we want to think about here. So with our change, that C portion, we're going to use a variable. Okay, in this case, X. That's what we're using for our change because we don't know exactly we don't know that change our X yet. That's what we're really trying to find using this ice chart. We go from 2, and then we have 0 for our product here. So right now, we don't have any products. We don't have nothing. But we understand, right, as our reaction goes forward, right, we're going to be making products, right? We're making our products, of course. So you got 0, you got to make some type of products, right? So we're going right, right? We're going right. Okay, so we're going to the right, we're making our products. So if we're going right to reach equilibrium, that means that we're losing our reactants and forming our products, right? Our reactants are being consumed to make our products. So, right, if we're losing or being consumed for our reactants, our X will be minus X minus X. That's all we can do. We're losing reactants. And then for our products, we're making products, so it's going to be a positive X. Now, once we have our C in place, then we have our equilibrium. In this case, you could just put for your E, combining our initial and equilibrium conditions. So basically, I just have everything engulfed in one thing here. 2 minus X, 2 minus X. So once again, 2 is our initial for I2. Minus X is because we're losing, because we're reactants, right? And then we're doing the same thing for both places. Product side is 0 plus 2x, right? 0 for our initial conditions plus our change in our 2x. Now, where did this 2x come from, Dr. J? The 2x came from our coefficient, right? Remember that we're just going to put our x with our coefficient. So if it was a 3, it'd be 3x. If it was a 4, it'd be 4x. From here, right, and this is it, just retold what I mentioned before, initial concentration minus coefficient of x. So in this case, it was 2 minus x for our I2 and H2. Then initial plus the coefficient times our x. So in this case, 0 plus 2x. Well, that's just 2x. Step 2, you want to write out your equilibrium expression. So if you guys forgot how to do that, check out those other videos. But this is our equilibrium expression. Products over reactants, right? So we're literally getting this from our chemical equation. We understand that I2, H2 gives me 2HI, right? So products, HI, and then 2, right? Because that coefficient is 2. and then H2, I2 on the bottom for our reactants. And then we're going to set that equal to 16 because they give us our K, right? So they give us our K. Now from here, this is where we can start plugging in different things. We can plug in our equilibrium expression, right, that we found, our equilibrium conditions. So in this case, this 2x, we're going to plug into our HI here. This 2 minus x for I2 and H2, we're going to plug that in here. So it's 2 minus x, 2 minus x, equal to 16. So what can we do from here? So from here, we can solve for our x. 2x squared and then 2x minus times 2x minus. So if you remember, right, our algebra, you know, that is never going to go away in chemistry. We could combine these together, and then it's going to look like this. 2 minus x squared. And then we have it set up to where now we could just solve for x. So basically, we're not even doing any chemistry. We just doing straight math, okay? So, you know what I'm saying? Definitely bring out those calculators. Brush up on those algebra skills because we about to do a lot of math with this type of equilibrium stuff. So from here, let's see what we got. We got square root 2x squared, 2 minus x squared equals to the square root of 16. Now, why am I square rooting both sides? To get rid of this squared, right? So that's squared, that's gone. And then we got square root of 16. So now we got 2x all over 2 minus x equals 4. And then we can just cross multiply. You know what I'm saying? Remember that this is over 1, so it's going to be 4 times 2 minus x, 2x times 1. So it's going to look like this. 2x equals 4 times 2 minus x. We got to distribute. So you got to remember 4 times 2 is 8. 4 times minus x is minus 4x. And then we can just solve for x. So in this case, we need to combine our x's together, add my 4x to both sides. Now I got 6x. And then I just need to divide my 6 to get that by itself. 8 divided by 6, my x is 1.3. Now, am I done? No, I am not done. I'm not done. So we need to go to step 3. Once we find our x, now we can plug it back into our equilibrium conditions that we found from before. So if we remember I2H2, we had 2 minus x. We know the x now. Let's plug in our x. 2 minus 1.3. That's going to be 0.66 molar for my equilibrium conditions. So at equilibrium, right, concentrations for I2 and H2 have went down from 2 to 0.66. That's how we got to think about this stuff, y'all. So, can I find my equilibrium conditions for my HI? Yes, I can. Because we got 2x. I know my x now, 1.3. So let's do 2x, which is 2 times 1.3. That's going to be 2.66. So it's saying that at equilibrium, we're going to have 2.66 for HI. So we went from 0 to 2.66 at equilibrium, right? And if y'all remember at equilibrium, right, our rates of our products being made and the rate of our reactants being back to reactant, right, made will equal each other, right? Those rates are equal to each other. When those rates are equal to each other, basically the reaction is over, okay? So, step 4, if you ever want to double check, right? We said that our equilibrium constant is 16. I know now that my concentrations are 2.6 for HI and 0.6 for I2 and H2. I can just plug those back in. And then what you're going to do, plug those in, 2.6 squared, 0.6 times 0.6. That's going to give me 16, which is my equilibrium constant. So your concentration should always give you whatever your equilibrium constant is. This is how we can double check to make sure it's correct.